We will discuss the complex analysis assignment 1 problem 3rd, that is a C. So first of all we need to put denominator z square plus 4 is equal to 0 to find the singularity. So we will get z is equal to positive negative 2i. So we will get the singular point, that is z is equal to positive negative 2i, and the given center, that is negative I. A is equal to negative I. So we can find the radius of convergence. So radius of convergence is the smallest distance between singularity and center. So that is r is equal to minimum of the distance between singularity, that is a 2i, and negative I, and negative 2i and negative I. It will give the minimum of mod of 3i and mod of negative I. This value is equal to the minimum of 3 comma 1, and this minimum value is equal to, that is 1. So now further from here we can find domain of convergence. Domain of convergence, that is mod of z negative a less than r, that is mod of z positive I less than 1. So we can construct the domain. So this is a required domain, that is mod of z plus I less than 1. The given function f of z can be written as 1 upon z square for 4 is equal to 1 upon z plus 2i and z negative 2i. So this value is equal to 1 upon 4i, that is 1 upon z negative 2i negative 1 upon z plus 2i. So now further, either we can see that our domain is, that is z plus I. So in Taylor series z plus I should be there. So we will adjust here like 1 upon 4i 1 upon z plus I negative I. There is an adjustment of positive I, and negative 1 upon z plus I negative I plus 2i. So 1 upon 4i, it will give 1 upon z plus I negative 3i negative 1 upon z plus I. Simplifying, we will get positive I. So now we will express this in the standard form, that is 1 upon 4i. Take negative 3 as a common, 1 upon negative 3i as a common, 1 negative z plus I over 3i, negative take the I as a common, we will get 1 plus z plus I over I. Further simplify, as we can say that, as we know that I square is equal to negative 1. So now from here we can write the I as I is equal to negative 1 upon I. So that is 1 upon negative I, 1 upon negative I, 1 upon I, and negative 1 upon I. So this can be written as 1 upon 4i, that is 1 over 3, that is I over 1 plus I times of z plus I over 3, and here will be plus I over 1 negative I z plus I. Now this can be written as 1 upon, now multiply the whole bracket I 1 upon I to the whole bracket. We will get 1 upon 4, 1 over 3, and this can be written as 1 plus I over 3 times of z plus I whole inverse, and that is 1 negative I z plus I negative 1. Our standard series, that is 1 over 4, 1 over 3, that is a 1 plus z inverse, that is a 1 negative I over 3 z plus I over 3 z plus I whole square negative I over 3 z plus I whole to the power 3 plus dot dot dot. Now further here will be plus 1 plus I times of z plus I plus I times of z plus I whole square plus I times of z plus I whole cube plus dot dot dot. We have used here our standard series 1 plus z inverse 1 negative z plus z square negative z cube plus dot dot dot, and 1 negative z inverse, that is 1 plus z square plus z cube plus dot dot dot, and define for all z mod of z had to be less than 1. Further simplifying above expression, that is 1 over 4, 1 over 3 in bracket 1 negative I over 3 z plus I, that is negative 1 over 9 z plus I whole square, and that is plus I over 27 z plus I to the whole power 3 plus dot dot dot, and further plus 1 plus I times of z plus I negative z plus I whole square negative I z plus I whole power 3 plus dot dot dot. So now here this value is equal to 1 over 4, that is 4 over 3, and that is positive 8I over 9 z plus I. So now here will be, that is negative 28 over 27 z plus whole square. Now here will be negative 80I over 81 z plus I to the whole power 3 plus dot dot dot. Divide the whole term by 4, that is 1 over 3 plus 2I over 3 z plus I negative 7 over 27 z plus I whole square negative 20I over 81 z plus I whole power 3 plus dot dot dot. So this is a very quite, we can say, the Taylor series expansion of the given function f of z, and this is a very quite final answer.